Thank you again to those who are joining and continuing to join. We are going to be talking today a little bit about the true cost of filter ownership. So what are your air filters actually costing you? When most people are evaluating air filters in their buildings, the conversation usually starts and often ends with just purchase price of those filters. But in reality, there's actually much more to it, and that's just one small piece of the equation. Today, we're going to explore those hidden costs from fan energy, maintenance to equipment performance, and show how looking at the total cost of ownership can really change the way that you're looking at filtration and just your overall HVAC costs in general as on an ongoing basis. Just before we begin, and I'm going to flip it over to our speaker, Luis, who will introduce himself and will be our presenter for today. Just wanted to go over a few housekeeping items. So today's session is going to run for about 45 minutes until 1:30. We're going to have the presentation, and then we're going to bulk about 15 minutes for questions. So if you do have any, please feel free to leave it in the Q&A section that you'll see in your menu bar. You can leave it in the chat as well. I can navigate between both, but preferably into the Q&A chat. And then we'll get through as many as we can at the end of the session. Everything that we're presenting today will be recorded and sent over along with the presentation, and then any other tools that we mentioned throughout our time today, we will also share in a follow-up email as well later this week. Without further ado, I'm going to pass it over to Luis, my fellow colleague, and he will be showcasing a great presentation today and hopefully will be very insightful for you all. Thanks.
Good afternoon, everyone. Thank you for joining me today. My name is Luis Marquez. I'm a professional engineer and a certified air filtration specialist with NAPA, and I am VP of engineering here at Blade Air. My background is in aerospace engineering. I did some about 5 years in consumer electronics, and I'm now in my 5th year with HVAC filtration and indoor air quality solutions. So in this session, we're going to really talk about why just looking at filter purchase price might be the wrong variable to optimize. We'll take a look at the different cost drivers that really drive the total cost of the filter ownership. And we'll kind of detail how low pressure, high dust holding filtration can really shift the math. And we'll take a look at real numbers, including kind of what we use at Blade Air as our intake form to create ROIs and show the performance of your filters in specific buildings and situations. This is kind of the table of contents. Again, as Ava mentioned, if you have any questions, write them into the chat and we'll make sure to answer as many of them as possible, or all of them ideally, at the end of the presentation during the Q&A. The question is, what if the price tag is only the tip of the iceberg? As we've alluded to, there's different things that can contribute to increasing costs or the true cost of a filter. And it really goes to what is operating behind that filter, right? Oftentimes, and I see this all the time, you're sizing HVAC equipment, or you see this very nice RTU or air handler unit that costs thousands, if not tens of thousands of dollars. And you don't really want to think about the filters, right? It's super cheap. Most of them are $10 or less. And, when you have tens of thousands of dollars of equipment, you don't really want to think more than that. Put it in, it's a filter, it works. Maybe, some will consider MERV rating. And so, okay, it's a MERV 8 or a MERV 13. Get the cheapest one that's properly MERV rated, and on we go. That can be really wrong. And something we like to kind of highlight here at Blade Air, it's kind of the equivalent of your oil change for a car, right? The oil change in and of itself is not a very expensive thing to do, but I think we all understand what happens if we just kind of ignore the oil change or not perform it at all. The value of the car really, really depreciates, and you're probably going to be looking at some engine repairs or other more expensive items if you just ignore it or, pretend like it's not something that you need to address or think about just because it's not as costly as other pieces of the equipment that are more expensive. Where does the filtration cost really come from? There are five main cost drivers that make up the total cost of ownership. Really, the purchase price is just the beginning. The one that's very direct, very easy to understand is the capital costs. That includes obviously the purchase price of the filter, the freight, so the shipping, and then of course the installation. These can all vary depending on where you're purchasing the filter, the type of filter, and if you're installing in-house with your own team, or if you have to outsource the installation, maybe for more specific equipment. Secondly, is the energy costs. Every piece of equipment, the fan needs to overcome the pressure drop and the airflow that comes with it. We'll really study how the filter itself can really add to this, as we'll find out it's a very large part of the cost. Next is the replacement costs, essentially when you need to change it out, how often you need to change it out, how much are these new filters costing you, and how long is the change out for the labor for this. A smaller one that many don't consider is the disposal cost. Generally, it's not very expensive to dispose of filters or really anything else. Most people just say, yeah, we just throw it in the garbage and the garbage disappears, right? We don't really need to think about it, but it is an actual cost, and especially when you're handling hundreds of filters, if it's somebody who actually has to move that around, that labor cost can really increase. And then as we'll study after, if you are considering things like CO2e removal and waste and carbon credits, then this can actually be a very large part of the cost. It no longer is a small one. And then finally, the one that really touches on with my analogy with the car and the oil changes is the equipment life. At the end of the day, the filters are there to protect the more expensive equipment, right? And so when the filters are not functioning, it creates strains on the fans, and that can lead to failure or freezing of the coils and motors, or other more sensitive equipment. At the end of the day, if you're paying for an air handler unit that's meant to be used for 15 years, you don't want to be replacing it in 8. Or if you're buying a bigger one that's meant for 30 years, you don't want to be replacing it in 18. When we look at the cost iceberg, as we like to call it, energy really dominates a filter's lifetime cost. These numbers are taken out of the NAFA guideline to air filtration, and so what you see here is the big number, obviously energy, using 81% of the entire cost of the filter. Now, this is all very relative because at the end of the day, if you have a super cheap filter, then yes, this number percentage-wise is going to be a lot higher. If you buy a very expensive filter, then naturally the percentages will be lower. The other things are like the size of the equipment will make these vary. But I think the big deal is to understand why the energy ends up always being the largest factor. At the end of the day, most of these systems are measured in kilowatts, sometimes in megawatts of energy, which really tends to add up. And the longer that filter stays in there, the larger that the energy tends to consume. At the end of the day, it's how much pressure drop we're adding and resistance we're adding for that fan to really have to power through. And depending on the price of your filter, that's gonna make up a large percentage. The rest is mainly on the investment and the maintenance. So that's the capital cost plus the replacement cost. Again, if you just consider the filters themselves, it may be really cheap. But once you start to consider what the labor is, what the install is, what the maintenance is, it can add up, right? A bag filter that's really heavy is going to take a lot longer to swap out than a light pleated filter. Or if you have, a washable filter that you have to leave out to dry, that might impact your runtime in your actual production. Or you may need to have twice as many filters so that you're not waiting for them to dry. Things of this nature is what we want you to start thinking about as you consider really what your filter is doing and what your equipment is meant to do, and kind of maximize that production and that value. And then lastly, we have the disposal. In this example, it's about 0.5%. Again, this is from a dollar value, which I think is what most people care about. But if you are, again, into carbon credits and CO2e scope emissions, this actual disposal might be costing you a lot more than you might think. Capital and replacement costs, these are what you see on a quote. Buying, installing the system, and replacing them again and again over their last lifetime. These are the most visible costs. They're the ones that show up on the invoice, and the ones that you need to approve for your facility. And so really the costs, inbound freight, some things that people don't consider sometimes is storage, right? If you're having to pay square footage, a lot of large facilities will want to store the swap outs for an entire year at a time. And so they only take shipments once a year, but then you need to hold those and be able to have space for that. Holding frames, clips, gasketing, caulking, and then labor to install the system. That's always going to be a cost. This really depreciates over the life of the installation. Then we have the replacement costs. Anytime you need to get new filters on every change out, that's somebody that has to get those filters, move them to the actual equipment, remove the equipment. Some things that a lot of people don't realize is the actual amount of boxes, right? I've gone into many systems where there are dozens or hundreds of filters, and for many of these, is a full-time all-year job, because most of the things is just moving boxes from into a rooftop over and over again, up and down. And so this really adds up in the cost. Obviously, the cost is driven by the frequency of those swap outs, and inherently the filter life or the dust holding capacity. A longer filter life will result in fewer changes and naturally a lower annual cost. The energy, really the biggest cost driver. Every filter resists airflow. The fans push through this resistance, and depending on system, it can be up to 80% of what the actual filter is costing you. And so from an energy perspective, looking at the pressure drop is really the most important number on the sheet. Now, most sheets will list the initial pressure drop, right? And so that's only but one number. That's really where it starts. And, most filters are designed to start at a very low pressure drop. However, as the filter loads, this pressure drop increases over time. And so a really more useful number to think about is what your average pressure drop is going to be over that filter's lifetime. Obviously, depending on how your system is operating, a 24/7 system will pay more than one that's being operated less. The efficiency of the motors and the drive efficiencies, typically this will range from 50 to 70%. And then this is the energy equation for airflow. Now, something to note here is this is a mechanical energy, and so the efficiency of your system to convert electrical to mechanical is really what will drive that efficiency factor and increase that energy. So what does it mean in dollars? And again, these are samples from the NAFA guideline to air filtration. A $4 pleated filter will consume about $34 in fan energy. And that's where they get that 80% number. Now, the thing to note here, and something that I'll highlight as we go through, is really what that means in terms of the actual life of the filter. If this filter is being swapped out every 3 months, that's really $38 every 3 months. It might be a lot higher a year. And so resistance rises as the filters load with dust, and essentially lower average pressure drop is direct recurring savings. Disposal cost is small but real. These filters do carry weight, they carry volume, they carry handling costs. Fewer changeouts is just less landfill volume, less hauling fees. And again, if you care about the emissions, it's really good on the low end of the scope 3. To lower that, that's usually the hardest ones to address. The one that's really, really big and a lot of us conveniently ignore is the equipment life, right? The high static pressure strains the fans, belts, and motors. I think that one, even as an industry, we kind of overplay a little much, right? We make it all doom and gloomy. It affects, at the end of the day, if the fan is sized right, it shouldn't just, blow up, but it will cause a strain, and you see that in the energy cost. The biggest thing I would highlight here is when you don't change your filters, let's say, the cheapest way is just don't change the filters, then you don't buy any filters. I've seen this happen, and what happens is they get so loaded that they actually start to bend, collapse, and get sucked into the system. I've been in data center units. I've been in hospital buildings where we've seen this, and there's literally no filters. All of the dust is going in, and then you see what the next thing is. The poor filtration results in the coils failing. They start freezing over. Then you need to pay for a much more expensive coil cleaning, sometimes replacing the actual coil. You're cutting your heat transfer efficiency. And so you start getting all of these things. And, 10 years down the line, you need a new RTU or a new air handler unit and all of the expenses that actually come with that. And so lower resistance and cleaner air really extend the life of the equipment itself. Comparing what I've been highlighting across a few different scenarios, I kind of compared using a modified version of the table that's in the NAFA guidelines to air filtration. And so this assumes a 24/7 operations, 8 cents per kilowatt, and a drive that's working at 58% efficiency. We assume a typical 2000 CFM per filter, that's about 500 feet per minute, and what's the standard maximum. Usually you won't see on a standard building going over this, or at least you shouldn't. I put here the average pressure drop. Again, most data sheets, including our own, will state all the initials and the finals, but really it's how you get there that's really important, right? We have a MERV 8 pleated filter that might start at 0.35 inches of water column and go up to 1. And it's really nice price, $4. Swapped out every 3 months. That'll give you $16 a year. And it's costing you, this is just math from the pressure drop, just under $200 in energy. So your ongoing is about $215 a year. Your MERV 13 bag, it's got a little bit higher average pressure drop, a little bit higher cost. You're getting better efficiency, right? You're getting MERV 13, so that's really good. It dust loads about 2 to 4 times more than the pleated filter, and so it can be replaced just once every 6 months for $70 a year, and your energy is a little bit higher, so your total cost is about $304. You are getting better air quality, so that there's a plus there. You look at your box, your rigid filter, maybe 12-inch deep or so. You'll get a little bit less average pressure drop, a little bit more pricey, but maybe you only need to change it once a year. And so that replacement is just once a year. Your energy, your ongoing, you actually end up a little bit cheaper than the bag in this scenario. When you look at the Blade Air Pro filter, we'll start at the same 0.35 as the MERV 8. Our max pressure drop is actually 0.85 because we dust load about just under 8 times as much as the pleated filter. We'll actually dust load more than the bag. It's a much higher initial. We'll put it at $200. But the replacements are actually more comparable to the MERV 8s. So we're actually only at $20 for the replacements. And so because of the lower average pressure drop, your energy per year is actually a lot lower, and your ongoing, because it's only $20 for replacement a year, actually ends up being the lowest price ongoing. And you still get that MERV 13 efficiency that the bag and the box are giving you. So you're getting better air quality, better energy savings. And because the frame is hard, you actually don't dispose of that part. And so you're saving on your disposal and your CO2 emissions. The Pro filter really works because it attacks all of the drivers at once. It comes in standard sizes, drop-in retrofits. So you don't really need new equipment. So you get that nice capital cost, and then the replacements are actually more comparable to a MERV 8 filter, not as much as a bag or a rigid filter. The energy cost just goes down to the lower pressure drop. It starts working immediately, and the more you use it, the more energy you can save. The big one is the replacement cost. The secret sauce, if you will, because this applies to all filters, not just the Blade Air Pro filter, but our biggest thing is the longer service life. Because we can dust load a lot higher, it results in fewer changeouts, in less labor, and that lower average pressure drop, not just the initial, but in the overall average. And so then disposal costs also gets less with fewer lighter spent filters, because our replacement filters are very light. They actually come in little Ziploc bags. You're able to carry 30, 50, even up to 100 in a single box, and that one person can carry. That makes it a lot easier and quicker for those facilities that have dozens or hundreds of filters to be able to actually swap out their filters efficiently. And then lastly, the equipment life. Again, that MERV 13 allows for better filtration that protects the equipment. And then because of the capital fixture on the frame, which is made out of aluminum, it will not, even if you decide not to change the filters, because it's made out of metal, it's not going to get it's not going to collapse, and it's not going to get sucked into the system like some of the cardboard frames will. And so that's an added protection. When should you actually change your filter? What's the optimum change out point? Filter cost per hour will fall the longer that you leave the filter in there. So the moment you buy it, it's at its maximum cost, and the longer you leave it there, the lower the price per hour. The energy cost inversely rises as the filter loads and as the pressure drop rises. And so really what you want to find is the sweet spot to change out at the bottom of the total cost curve and not just at the calendar. So obviously, as you see here, this is for this specific scenario is in that 3-4 months. And that's where you actually get that manufacturer's recommendation on the pleated filter. With the Blade Air Pro filter, what we do is we flatten out that pressure drop curve, which flattens out this energy one. It brings it lower, which lets us extend out that lower 3.9 number you see on the graph, extend it out further to 6 months, 12 months if you've got really clean air. And that's where we can really maximize that cost, because then that's less labor costs, that's less swap outs, that's less change outs, that's less CO2 emissions. All of these things trickle down into better savings. I'm going to show a quick live demo of our Blade Air ROI calculator. It is from an actual real project. We've kind of anonymized it, so we don't send out any sensitive information. It is an institutional facility, and it's looking just at one air handler unit that in this scenario is running 24/7, 365 days a year. We have some of the baseline energy numbers. It is at 8 cents per kilowatt hours. And the actual setup was 2 pre-filters. It actually had 2 pre-filters and 1 main filter, 12 filters each. And they were doing 4 changeouts a year, serviced in-house. And with the Blade Air Pro filters, we actually removed the main heavy loading filter and took 2 of the slots of the pre-filters. One is a pre, one is a main, and had 2 changeouts a year. These are kind of the savings that went along with it. The first thing is we kind of send out this client and site information form. I've nicely named our institution, the Blader College for the Arts, at the address. And just because this was in Manitoba, I put that as the location. And these are kind of different MERV ratings and different dimensions for each of them. They actually gave us the costs of each of their filters. So their pre-filters were $10 and $7 each for the different sizes. And they had some bigger rigid filters, actually. You can see they were 6-inch thickness, and they were a little bit more expensive. With some of the other details, we were able to create what is our ROI calculator. So I've kind of created a project here as a sample. So it's a Manitoba, and it's an education industry. And I've actually created the ROI for this. Some of the things that we do, we create your building, and in this building, we create kind of the air handler units. These are provided to us every 3 months. We have the 9 MERV 13 filters, and we have the Pro filters. This actual unit was 24 kilowatt hours that was given to us on the size, and we estimated saving 20% because we were able to fully get rid of one of the filters. And so what this gives us, we actually print out all of the details and send out a proposal that you can share with your client, your property manager, your end user. And so using the data that's been provided to us, and I'll just scroll really quick to the bottom, we actually put in the air handler unit, show all the details that were given to us. We show what the existing filters are, what our Pro filters are going to be. We price them in $200 per unit, $20 per replacement, and we get this nice summary. The break even for this project would be 6 months. They're expecting to see 85% in annual operation savings. We reduce the filters from 36 to 24. We actually do calculate the GHG reduction. And so this is just one air handler, 210,000 kilowatt hours. The operating days, we get the annual energy saves, what that is in actual dollars, and what your total savings would be for 5 years. In 5 years, you'd be saving about $56,000. And what's really neat is we don't hide anything. All of the information is here, and we're able to modify it for you. In this case, because we're eliminating a filter, we went a little bit more aggressive at 20%, but generally we're somewhere between 15 to 30%, depending on your system. This one is 24/7, so that's added there. One thing is the GHG reduction was actually quite low on this one because Manitoba has a really clean grid. But something I wanted to show is, what if this same thing was done in a dirtier grid like Alberta or someone else? We can check our configuration. And I want to say, you know what? Let's go from Manitoba to Alberta. And what's going to happen is our grid emission factor here is going to change. Here you see I can change the runtime in hours. I can change the operating day. I can change the cost per kilowatt. These are all things that we're able to change. Is the labor in-house, not in-house? Logistics, in this case, they're changing every 3. They actually take shipments only once a year. So we have that into the account. For our Pro filters, it would be the same. How much is being paid on the housing of the filters? These are all things that we can work with you for you. We actually have a health and wellness. Most people don't consider these. So we have this as 0, and I can save my changes. I'm going to publish them, and I can see what these changes will look like on my proposal. Now, I didn't change any of the energy, and so my dollar values are going to be the same for this. But if you look, my GHG reduction now skyrocketed because eliminating this much energy from the grid actually results in a lot of CO2 savings on this, right? Equally, I can change other values like what is the hourly rate to service. We include the installation costs, right? So when they put in the pro filters, it costs them a few $1,000s to actually swap that out. All of these things affect your ROI, but we can calculate that for you so that these are numbers that will make sense for you. And we have all of our emission factors. These are provided from the government of Canada, or if you're on the US, from the EPA website. And we show this for all of you. We can modify what your price is. You see the monthly breakdown. This is a break even and where all your savings will go. And so this is something that we do for you. We can send you the proposal form and work with you so that you feel very secure in what you're going to make. Evaluate your filters on the cost of ownership, not just on the purchase price. The energy bill is part of the bill, operational costs, who is actually going on there to make the change, how long they're actually going to take. Find your dominant cost driver. Is it your runtime? Is it the energy rate, right? The different locations have different energy rate. Is it labor or servicing contracts? Let that guide your filtration strategy. Reach out to your certified air filtration specialist. Track your pressure drop and change the filters at that optimum point, not just by the calendar. Understand if I visited a client recently that they were bought beside a train station and train tracks, and their filters is just getting loaded, super filthy because of this extra added layer. And then run your own numbers, right? We'll share the Blade Air ROI calculator. We can calculate what makes sense for you and what can make sense for your facility so that it's able to get the biggest slice of the pie.
Awesome. Thanks, Luis. We do have a few questions. I will lob them over to you in the order that they came in. First questions, how are our replacement costs only 20 a year, but the initial cost is 150? Can you just clarify the cost?
Yeah, yes, great question. So with the Blade Air Pro filter, we have a hard aluminum frame. Think, what your filter currently looks like, but kind of made of light aluminum. That stays in your system as part of the capital expenditure forever. We basically guarantee it. Like we have filters out there that have been over a decade. Essentially, it'll last as long as your equipment. What you replace after that is just the inside media pad, which is a lot lighter. It actually comes rolled over like in like a little Ziploc. Maybe I've got one here beside me for those watching. This is what it looks like. And so there's only one because I ordered one, but actually two fit in here. And so you could stack these in a box, and they're only a fraction of the price forevermore.
When you say the Pro Filter has a longer service life, under what conditions was this determined? How will this change for areas with a lot of air impurities like near pollens compared to other filters out there, which you briefly did touch upon with that example at the end there? So will allow you to build.
From a lab perspective, we dust load just under 8 times more than what a standard pleated filter. If you look at a standard system, a lot of them will stack a pre-filter, a pleated filter with a main larger bag. The reason they do this is because the pre-filter is just there to protect the bag, but the bag is doing the heavy lifting and the dust loading. The bag will actually capture a lot more, and that's where you get maybe the pre-filter being swapped out every 3 months and the bag being swapped out every 6 months or a year. For us, because of our technology, we are able to dust load even higher than the two combined. And that's where, in general, we'll say you're probably good to go twice as much as your current swap outs. In terms of actually measuring and how you would want to do that, ideally, pressure drop is what most people will use. That will let you know at the end the pressure drop in a standard pleated filter or the bag is generally around 1 inch per water column, or 1.2 in or 1.5 in certain bags and rigid box filters. And so you want to make sure you swap out before that. But depending on your system, as we showed with kind of this graph, you may not want to necessarily go to the max pressure, right? You'll save more energy if you swap it out early. Now, the problem is if you swap it out too early, you're going back to your capital costs. And so if you have a very expensive, right, I know some box filters will be $150 each. Well, if you do that every 6 months, that's going to add up quite a lot too. And so that's where being in the sweet spot for your system is the ideal, because if you're in Toronto where I'm located, generally the air is very clean. You're going to be able to leave it there a little bit longer than in another place and let that max out on the energy and the capital costs and then swap out. But if you're like the client that I visited yesterday and they're right beside the train station and the track, you don't, it's going to dust load in a month. And so there's actually swapping out every month because it's dust loading so much. And so understanding your system and being able to swap out smartly is really what it is about. It's how much is your filter costing you to operate your equipment, not really how much is the price tag on your filter. That's the question we're trying to address. And we're happy to help with your specific system to make sure that whether you use a pro filter or not, that you're getting the smartest swap out for your specific system.
Are these filters compatible with a front load air handler or just a side load?
Yep, we've done front load, side load, no issues. We are custom made, so even if it's a very specific size, we can custom make to an exact in between, even if not nominal. Otherwise, if it is nominal, if you say it's a 24 by 20 by 2, you're going to get the equivalent 24 by 20 by 2 with the offsets as needed. And so no problems with the front loading, and it does have its own gasketing to have good fit as well.
If the cost of your filter doubles or say Blade Air goes bankrupt, what are the alternatives? Current filters have numerous manufacturers and are very easy to source. What is that alternative for us, and any comments?
Very, very good question. There are alternatives. As a company man that I am, I won't necessarily name them here. There are other companies doing similar technologies. We do it better, is what I like to say, but there are options. We have been in market for well over 20 years. We brought it in as Blade Air more into the commercial. It started off as more residential, but we've been in over decades of production and have a very large base. So we're good on that end, thankfully. But good question. We do get that question other times.
Can you talk about the savings difference between a variable frequency drive versus a fan that doesn't have the ability to slow the fan down?
Yes, I can. It's so the easy one is the variable frequency drive. For those that may not know, this is when the fan motor will adjust to a specific speed. What that means is with a lower pressure filter, it's going to be able to reduce its energy automatically, and you'll reap those benefits in the energy savings. What can happen is if you don't have this and you have a direct drive, it's going to oftentimes, if not most times, actually increase the energy usage of that fan because you're going to be pushing more air. It's a very interesting question. I've seen it in many pilots. We've done a lot of direct fan motors. And what ends up happening is because of the efficiency or lack thereof of the systems, you actually see the savings in the runtimes, and more specifically, cooling and heating runtimes. One specific scenario, we were doing it was a large pilot with a large national bank. And one thing that we saw directly was the runtimes on their cooling. Basically, their system, when they came into office, would run and cool down to the temperature that it was set. Normally, I think it would run for maybe 40 to 50 minutes, depending on the day and the temperature, and then we would slow down to fan only mode. You could see it, the compressors would turn off, and we were tracking all of that. And what was interesting was after we put in the Pro filters, same exact system, it would actually every day it was like a minute or two less that it would run. But because the compressors were running at 3 times what just the fan only would run, each one of those days would add up. And in this specific case, we ended up saving actually more money on the direct than on the variable frequency drives. And so that was very interesting. I think what I would say is it'll really depend more on how inefficient the system is. A more inefficient system will see more benefits. If a perfectly adiabatic, perfectly efficient system would actually see no savings at all in a direct drive because it would just convert the temperature to energy. But the world is not perfect, and so no system is perfectly efficient. So you still see, sometimes you'll see even more than variable frequency drives. Sometimes you'll see less. That's kind of where we get our 15% average. With a variable frequency drive, it's a little bit easier to track on the math and the science. But again, we're happy to work these things for you for your specific system because it is dependent a lot on that.
Would your installation require a retrofit to the equipment?
No is the very short answer. The biggest thing, for those that may not know, the filter is powered. It uses a very low 2 watts. Fans and equipment runs in kilowatts, so it's about a cup of coffee for a year to run. And so generally, if it's a small system, say 2 to 4 filters, you can run them off the control panels. It's 24 voltage AC. Generally, for larger systems, we will recommend adding its own dedicated power. And what that really means is just having its own transformer. Regular 120 volt to 24 transformer will run you anywhere between $20 to $30. It runs on class 2, so you don't need to be a certified electrician to do it. For most locations that have their own staff, they will do the change and install the transformer themselves. For the really big facilities, they also prefer to do that. We also work with partners. Like we were at a facility yesterday. They just wanted turnkey. They have their own staff, but they're busy working on their own equipment. So we have our partners and we provided that for them. And so we're happy to work with that. We are releasing a new control panel that will include a transformer, a very fancy piece of equipment. Not everybody needs it, but it's certainly available for those. And really that's the biggest, that would be the biggest thing. And again, it's a $20 piece of equipment that you only install once. And then after that, you're literally just unplug it the same way you unplug your phone from your charger anytime you're going to do the swap out. If you do connect it directly to the controls, you have the added benefit that when you do service the equipment, you turn off the equipment, it turns off the filters. So they only turn on when your equipment is running.
Thank you, Luis. Thank you all for joining this afternoon, if you're on the West Coast this morning. And I hope you all have a great day and look forward to seeing you on the next one. Thanks, everyone.
Thanks, everyone.